Welcome students. In this lecture, we learn pin diagram of 8085. After that, we see about microprocessor 8085. In previous lecture, we already learned what is a microprocessor and evolution of microprocessor. So 8085 microprocessor is the second generation microprocessor. The first general purpose microprocessor. So 8085 microprocessor, this microprocessor is an 8-bit microprocessor. How many bit microprocessor? 8-bit microprocessor. As it operates on 8-bit. The size of address bus in 8085 is 16-bit. 16-bit size of address bus. Okay. The size of address bus in 8085 microprocessor is 16-bit. Thus, it can address 64 KB memory. 8085 microprocessor has an IC with 40 pins. IC with how many pins total? 40 pins and operate with plus 5 volt. Operate with plus 5 volt power supply. The pin configurer play a very important role in understanding the architecture of 8085 microprocessor. So now let's move further and understand how the processor operates inside any system with this 40 pins. But before that, we have a look at the pin diagram of 8085 microprocessor. See the diagram, pin diagram of 8085 microprocessor. Okay. In this pin diagram, there are 40 pins. How many pins total? 40 pins. The signal of this 40 pin IC is grounded into 7 categories, which are power supply. Okay. First is a power supply. Power supply, data bus, address bus, and serial input output port. Input output port, control and status signal. Control and status signal, as well as interrupt and externally generated signal. Interrupt and direct memory access. DME, direct memory access. These are the categories among which the 40 pins configuration of 8085 is divided. These are the categories: power supply, data bus, address bus, input output port, control and status signal, interrupt line, and DMA, direct memory access. Okay. Now let's start to see one by one these pins. Okay. First we see the power supply and clock signals. Okay. In 40 pin configuration, 4 pins are allocated to particular category, which category? Power supply and clock signals. See here, pin number 40. Pin number 40. Okay. The pin number 40 denote VCC. Here, pin number 40 as a VCC. And external power supply of plus 5 volt is provided in this pin. External power supply plus 40 divided by VCC. An external power supply of plus 5 volt is provided at this pin. Then next is a VSS. Here pin number 20. VSS. Okay. Pin number 20. Okay. At pin number 20, this pin shows the ground connection of microprocessor. Pin VSS shows ground connection of the microprocessor. Okay. Then next pin of power supply and clock signal are X1 and X2. Pin number 1 and pin number 2. This X1 and X2. These are represented by pin number 1 and 2. Here, pin number 1 and pin number 2 respectively. In this pin configuration, these two pins are connected with a crystal or LC network to maintain the internal frequency. Okay. This pin number 1 and pin number 2, these are connected with a crystal, or you can say these pins are crystal pins, okay, to maintain the internal frequency of the clock generator. These two pins used to maintain the clock frequency, internal clock frequency. Okay, these are pin number 1 and 2. Now next is next pin, power supply and control signals. There are clock CLK. Here pin number 37. Clock out. It is a pin number 37. Here pin number 37 of the 8085 IC and act as a system clock. Here act as a system clock that keep the record of time duration during by the each operation to get completed. This pin CLK out, pin number 37. This pin is a act as a system clock. Okay. Now after that we see the address bus. This category contains 8 pins. The address bus has a 16 line. Okay. Here address bus, we already see address bus in 8085. There are 16 address bus, okay, and 8 data bus. The address bus has 16 line, that is it carries 16 bit. Carries 16 bit at a time. However, out of 16, 8 are multiplex. Here, these are the pin number 12, 20, and pin number 21 to 28. Here, pin number 12, 20, and 21 to 28. These are the address bus. But out of 16, 8 are multiplexed with the data bus. These 8 are multiplexed with pin number 19. Okay. Here, pin number 12, pin number 19. These are the multiplexed address bus. Out of 16, 8 are multiplexed with data bus and left over 8 are separately shown by pin number 21 to 28. Here 21 to 28. Okay, separately shown by pin number 21 to 28 in the pin configuration. These are used to carry address of data and instruction. These are carry address bus. These are used to carry address of data and instruction from the processor to the memory location and unidirectional in nature. The address bus are unidirectional in nature. Keep in your mind every question having address bus. In this chapter, every question, one point is written on address bus. So address bus is a unidirectional in nature. These are denoted by AA to A15. Denoted by AA to A15. AA to A15. That represent the 8 MSB. That is most significant of memory location or input output address. Now next is data bus with multiplex address bus. Here these are the data bus AD0 to AD7. AD0 to AD7. These are the data bus. Okay. It contains 8 pins. The size of data bus of the 8085 microprocessor is a 8-bit. Size of data bus is a 8-bit. To reduce the number of bus lines, these 8-bit data bus lines are multiplexed. Here, address bus and data bus. These lines are sometimes act as the address bus and sometimes act as a data bus. Okay. This bus sometimes act as address bus as well as data bus. These lines, 8-bit data bus lines, are multiplexed with the 8-bit address bus. Okay. The pin number 12 to 19. Yes, pin number 12 to 19. These are the address or data bus multiplex line. The address bus is denoted by A, whereas the data bus is denoted as D. Address bus denoted by A, whereas the data bus denoted as D. Okay. The pin configuration denote the lower order multiplex address and data bus bit from AD0 to AD7. Here AD0 to AD7. This denote the lower order multiplex address and data bus bit from AD0 to AD7. We have already discussed that the address bus contains the address of desired memory location from where the data or instruction is to be fetched, while the data bus contains the data or instruction that is needed to be fetched from one memory. After that, we see the serial I/O ports. Serial I/O ports. We see power supply and data bus, address bus. After that, we see next point, serial I/O ports. It has basically two pins. That is SID and SOD. SID and SOD. SID denote the serial input data pin. SID, serial input data pin. This is the SID, and SOD denote the serial output data pin. Serial output data pin. Okay. This pin number 5, 4 and 5. SID pin number 5, SOD pin number 4. SID pin number 5. With this pin, data is serially fed to the processor. Using SID pin, data is serially feed to the processor directly through the input device. Here carefully, okay. Data is serially feed to the processor directly to this input devices using this SID pin. Okay. SID denotes the serial input data pin and its pin is the number 5. Okay. With this pin, data is serially feed to the processor directly to the input device. Now next is the SOD pin number 4. SOD denote the serial output data pin and it is pin number 4. Here pin number 4. In the pin configuration 8085, once data is processed, okay, once data is processed in the microprocessor, then this pin represents bit by bit result at the output device. Okay. Once data is processed in the microprocessor, this pin represents the bit by bit result. ये pin क्या करता है? SOD. This pin is represent the data, represent the result bit by bit at the output device. Again, I am repeat this pin number 4 SOD. And this pin represent the bit by bit result at the output device. Okay. Now next we see the control and status signal. Next is the control and status signal. In this, basically control and status signal having 6 pins. That is ALE, here, ALE, then RD, RD, WR, IOM, and S0 and S1. These are the state control and status signal pins. First, started from ALE. Pin number 30. Pin number 30 ALE. A is an acronym for address latch enable. The address latch enable and is the pin number 30 is a configuration. We know that 8 lower order bit of 16-bit address. These are the 8 lower order 16-bit address are multiplexed with 8-bit data bus. This pin gets enabled at the time when address is represented at the multiplex address and data bus. Otherwise, it gets disabled. Otherwise, it gets disabled in absence of an address of bus, showing the absence of address of bus. So the ALE is the address latch enable. It's pin number 30. We know the 8 order bit of 16-bit address. This 16-bit address, 8-bit of address data bus are multiplexed with the 8-bit of data bus. This pin get enabled and this works done through the ALE. Enable at the time when address is represented at the multiplex address and data bus. Now next pin is a RD. This RD, this pin number 32. Number 32. The low signal in this pin shows the read operation. When the low signal in this pin shows read operation either from the IO device or from the memory unit, thereby indicating that the data bus is now in state or position to accept the data from the memory or I/O device. This pin number 32. This pin is a signal. In this pin shows the read operation. This pin signal shows the read operation. This pin number 32 shows the read operation. Next is a pin number 31. Pin number 31 WR. Okay. Now this pin number shows the write operation. Okay. Pin number 31. This pin shows the write operation. A low signal in this pin represents the write operation at the memory or I/O device. This indicates that the data represent the data bus is to return into the desired memory address. This pin number 31 WR. This pin is a low signal to get the write operation. This return into the desired memory address or I/O device by the processor. The next pin is a I/O bar and bar. Pin number 34. Pin number 34. It indicates the selection of memory address or input-output device. This pin, here pin number 34. This pin 34 indicate the selection of memory address or input-output device. The read or write operation is to be carried out at the memory location or at the I/O device. The low signal at the pin shows the operation of performing over memory location. Next pin number is pin number 34. This pin number 34 indicate the selection of memory address or input-output device. Got it? Pin number 34, then read signal. Pin number 31 says the low time write signal. Here RD is the read signal. I/O, this indicate the selection of memory address or input-output device. Then next is a S1 and S0 and S1. Pin number S0 and S1. Here pin number S0, pin number 29 and S1 pin number 33. These pin S0 and S1 represent the status signal. This pin S0 and S1. These pins indicate the status signal. Pin number 29 and pin number here, pin number 29 and pin number 33. This signal shows the type of recent operation of microprocessor. Okay. See, when input output, when here this pin number 34, when input output signals are low, that means 0 or S1 also 0 and S2 also 0. That time data bus status is held in position. Now after that, if pin number 34 I/O and bar, this pin is 0 or low, S1 is 0 and S2 is also 0, S2 is 1, that time memory write. That time A denotes the memory write operation. Data bus status is memory write. When I/O is 0 and S1 is 1, I/O is 0 and S1 is 1, S2 is 0, that time memory read. And memory read operation. Here is also 0, that time memory read operation is performed. If all are in high or 1 if I, O and M, S1 is 1 and S2 is also 1, that time interrupt acknowledge. Okay, so the data bus status is a interrupt acknowledge. Now next we see, move on our next point, that is interrupt and externally generated signals. Okay, these are the interrupt lines. Interrupts line. Interrupt are the signals that are generated to break the sequence of ongoing program or ongoing operations. What is the interrupt? Interrupt are the signals that are generated to break or stop the sequence of an ongoing operation or program. When an interrupt signal is generated, then CPU immediately stops its recent task under the operation and switch to some other program known as the interrupt service routine. Denoted as ISR. After handling ISR, the CPU get back to main program for execution. In the pin configuration, 5 type of interrupt. Here, 5 types of interrupt. Trap, RST 7.5, 6.5, 5.5, INTR. Basically, exist 2 type of interrupt: maskable interrupts and non-maskable interrupts. Out of 5 major interrupts, 4 are maskable interrupts. That is INTR. Here, INTR. 35, 1, 2, 3, 4, 5. These are the interrupts line. Okay. There are mostly divided into 2 parts. That is the maskable and non-maskable interrupts. There exist 2 type of interrupts: maskable interrupts and non-maskable interrupts. Out of these 5 major interrupts, 4 are maskable interrupts. 4 are the maskable interrupts. These are INTR, RST 5.5, 6.5 and 7.5. These are the maskable interrupts, that is manageable interrupt. Maskable means that are manageable interrupts. And trap is a non-maskable interrupts and hold the most priority among all interrupts in 8085 microprocessor. Now, in this interrupt, firstly we see the pin number 6. That is reset pin number 6, 7, 8, 9 and 10. Okay. Got it? These are the interrupt pin. Now we see the pin number 36 reset in. Pin number 36 is reset in. Reset in. It is a pin number 36. An active low signal at this pin present the PC of microprocessor to 0 or low. Or we can say after resetting the PC, hold its initial memory address. This pin, and after resetting the PC, hold its initial memory address. Now next is the reset out. Here reset out pin number 3. Pin number 3. This pin generates a signal to provide information about the resetting of microprocessor. This pin, reset out, this pin generates the signal to provide information about the resetting of microprocessor. Also, we can say that once a processor is reset, then all the connected device must also be reset. When B. Processor is reset, then all the connected device must also be reset. Okay. Next pin, we move on to our next pin, that is INTA, pin number 11. INTA pin number 11. A signal at this pin acknowledge the generated interrupt. Okay. Acknowledge, generate the interrupt. Next. Now we see about the DMA. Our last point, that is DMA, we are aware of the fact that memory and IO device are connected with each other by the microprocessor. So the intermediator, that is CPU, manage the data transfer between input-output device and memory. Okay. CPU manage the data transfer between input-output device and memory. However, when data is a large amount is to be transferred between IO device and memory, the CPU get disabled. CPU get disabled. This transfer is manageable by external control. Transfer is manageable by external control circuit. So the DMA has two pins, HOLD and HLD. Here pin number 39 and pin number 38. HOLD pin number 39. This pin generate a signal to notify the processor that more than one request is present to access the data and address bus. When this signal gets enabled, CPU frees the bus after completion of reset operation. Here, pin number 39, hold. Okay. This name itself says it holds the some operations. Okay. So the CPU frees the bus after completion of reset operation. Once the hold signal gets disabled, the processor can access the bus again. Now next pin is a HLDA, pin number 38. HLDA, pin number 38. This signal is enabled at the time when the processor gets hold signal. The signal enable at the time when processor get the hold signal and it release HLDA, that is hold acknowledgement signal. HLDA, hold acknowledge signal. Next pin is ready. This pin number is a 35. Pin number 35. The pin that maintain the synchronization between the processor and peripheral. This pin maintain the synchronization between the processor and peripherals memory. It is clear that a microprocessor has a much faster response than peripheral and memory. So this pin is enabled when processor as well as the peripheral and memory both become ready. When the processor as well as peripheral and memory both become ready to begin the next operation. In this case, when ready pin is disabled, then the microprocessor is wait in state. When this ready pin is disabled, that time our microprocessor is in wait state. Okay. So all these are 40 pins. This is all about our pin description of 8085 microprocessor. I hope you understand. Okay. So we will stop here. Thank you, students.